Okay, so what we're going to do here is kind of give you a little bit of a tutorial on ArcHydro tools, and I'm going to use the end of Lab 2 where we were mapping subsidence across the Enoch Graben, and I'm going to try to extract this channel right here for you all. It's a small channel, um, but hopefully it provides a good example. And so most students have already kind of gone through the fill, flow direction, flow accumulation steps, but I need to do that here so we can then extract watershed, which has been challenging for some people because they didn't have good directions on that. So we will get to extracting a watershed, also extracting a stream polyline that we can intersect with this 3D surface and produce a long river profile, and then add points to that profile. Okay, so what I'm going to do is try to cut this LiDAR data to just this area that I have right here. So one way to quickly do that is we can go ahead and run our fill, and we will fill the data set that I'm showing here. And of course, this is the difference map over a visualization, but we're going to fill the USGS 1 meter DEM because we need to do that. Now I'm going to go to the environments and I'm going to process this over the current display extent. So it's only doing this area, not the entire area of the data set. So that should save me some processing. Okay. And yeah, I'll go ahead and do that. So I guess just a little running commentary while that's working. So remember, of course, that whenever we're filling these watersheds, we're operating on the DEM to produce a new DEM that doesn't have holes, hopefully, and allows water to continue to flow downstream. So if I just zoom out a little bit, you'll see that that new DEM, which is filled, is just over that area of the past screen area. So now that can be a good data set for me to proceed. So then I do flow direction. So input that filled surface and I create a flow direction raster. I can just run that. And so remember, flow direction is essentially the direction that one pixel flows to in terms of its neighbors. So it's kind of like an aspect slope facing direction sort of raster. So you can see it looks much like an aspect map. And next we go back and we do flow accumulation. So input the flow direction raster and create a flow accumulation raster and go ahead and run. This one is usually a longer step. So while that's going, I'm going to turn these off for a minute. So we're going to talk about this little watershed. So I'm kind of interested to see, since it seems that the watershed crosses the Graben, if we see some changes as it approaches that other side. That looks kind of curious. I guess there seems to be some man-made diversion, so that might make things a little challenging. But as it comes through here, we could see some changes in slope as it leaves the Graben. Up through into here, we can see it becomes more constricted and it's more incised here and less out here. So we should see some interesting things. Okay, now we can see the streams are starting to show up in there. So let's go ahead and go to symbology to dock this over here. So we want to change this to classify, and we want two classes, stream and no stream. And I like to go to the histogram and say, okay, no stream. And stream. That looks pretty good. Start with that. Okay. So back to the classes. Let's change this upper value. So this is 640,000 pixels. This is a 1 meter data set. I'm going to do 500,000, see how that looks. And we want this to be no color. And then we need this to show up. So let's make it black. That'll show up, sort of. Might have to go away from my difference map here and turn on the need a simpler view. Okay, let's go back to our fill DEM and then let's make this a bright yellow. How about that? Goodness. There we go. So are we satisfied with that? I feel like we want to show a few more streams, but in terms of extracting that particular one, it might be okay. I see, yes, it is connected. Okay, good. Yeah, I guess, let's see, does it come up to this small drainage here? Turn this off again. Does seem to, but I wouldn't mind it showing a little bit more. So go back to symbology, change this to, it needs to be, say, let's do 300,000 pixels. And then let's turn on that fill again. Now we're getting a little bit more in terms of drainages. Still not that many. Maybe I can tone it down to 200,000. Let's see how that looks. Maybe even 100. Now I'm kind of getting most of the major drainage networks. It's making me feel a little bit better about it. So yeah, let's proceed with that. Okay, so basically I've gotten a classification that if we have 100,000 of these LiDAR pixels, then we have a stream. So that basically we need to just go to reclass and go to reclassify. Whoops, not by table. Classify. So we input that flow accumulation raster and it ports, and we want anything less than 100,000, we want to make that no data. And then everything more than that, we want it to be equal to river, or I'm just going to call it the value 1. And go ahead and run reclass flow. So that should make another raster which just has values where the rivers are in our model. Oh, it doesn't look right, as we can see that the values of it are highly variable and they're supposed to be classified. Reverse new values, reclass flow 1. Go into the symbology of that. Let's look at the histogram. That is odd. That's not what should have happened. should literally be one color. No data, no data. River. How about that? No, it's not going to let me do that. Reclass 2, run. That's really weird. Well, that really shouldn't have happened. But we can fix this. We really don't want 9 classes, which is kind of what it gave us, isn't it? Okay, so what I'm going to do to solve this problem is you can see that it pretty much gave us correct values, and that if we look at either a reclass flow 1 or 2, it only has pixel values where they exist. So in fact, let's see if this is true. So if we go back to symbology, are there really any values other than 2? So let's go to classes. Actually, let's just go to unique values. And apparently there's some other values. There's 2 values of 2, and then also this other value, which seems to keep repeating. So what I'm going to do is this. So we can go to raster calculator. So that's within spatial analyst tools, map algebra. And we can say, let's just get, we just want to know wherever conditional raster class flow is equal to the value 2, then we want to have the value 2. Otherwise, we don't really care. And so we can call this reclass calc. See if that makes us a new raster that solves this problem. Hopefully you didn't run into a similar problem. Okay, yeah, so that did it. So now I have what I should have, which is just rasters of the value 2. So I can remove these other weirdos. Don't need them anymore. Okay, so if we go back to geoprocessing, so I have my stream, so I can go stream to feature. My stream raster is that new one. Then I put the flow direction raster. And then I get my polyline. There it is. I'm gonna turn off my fill so I can see that over my interesting difference map and slope map. So the stream that I was most interested in, where did it go? Okay, it's over here. All right, great. So it's this one right here. Okay, so I've got my stream. But now I want to extract the trunk stream. So I can go to my stream feature here, and it can go to select, and then I go to map, I go to the selection within map, and I click here. I want to add to the current selection and go from one side of the data to the other. So I go back to map, click select. Okay. Did it get it all at once? I might have done that because we don't have a lot of branches. Not everything, because there we have a join. So I need to select another feature here and another feature here. So just kind of work our way up. And then I have a choice to make as terms of what I think is where I want to take this channel. For this example, I'm going to go to the right here. And I guess I'll follow this. Oh, let's not do that. That's out of order. So we'll go back to map, change my selection to remove from current selection. Okay. Now I got to go back to map, add to current selection. Okay. Okay, now I'm done. Okay, so I've got my stream selected throughout the watershed, or throughout the data. So then I right click, I go data, export features, and I'm going to call this Enoch stream. And so that's going to export just what I've got selected, and that will be my new stream. I'll make it very obvious as this highway. Okay, and now I'm going to turn this other stream off. We should just see my new stream. Okay, so there it is. It somehow went outside of the data, which is a little strange. So from that, we can calculate a few things. We can hopefully get a profile out of that eventually. But first, let's show you how to make a watershed along this stream. Okay. So what I'm going to do is I need to basically make a snap point. Okay, and so I need to make a feature class. And so I'll go to View, and I'll go to Catalog Pane, and I'm going to go to this database. I'm going to, within that, make a new feature class. And I'm going to not give it Z values, just going to give it point file, and I'm just going to call it snap point. Okay, and that should be good. I'll go next, next, and let's make it the same coordinate system as the LiDAR. Okay, so here's my snap point up here, and it doesn't exist. There's no data, right? There's nothing in the attribute table. So that is, we need to add. Okay, so what we can do is go to Edit, Create, Snap Point, and then, yeah, you can easily snap to the stream, and that's great. But the reality is we want to snap not to the stream, We want this snap point to intersect this flow accumulation raster, which should be the same as this reclass raster. So I'm going to put that right here. Okay, where is it? Didn't create anything. There it is. Okay, so then once that's done, I click save and save my edits. And there we go. So from there, I can close create features, go back to geoprocessing, back up. And there's two things. So since this is sitting on the flow accumulation raster, this should probably work as is, which means I just go to Watershed and proceed. But if I really want to make sure, what I do is this. So I'm going to turn on the flow accumulation that we classified. I'm going to go to snap pour point, input raster or feature pour point data. So that's my snap point. And I'm going to choose the flow accumulation raster that it's going to snap to. And it's going to put an output raster, which is going to make a pixel that it intersects right here. I'm going to go ahead and run that. Okay, so that's the pixel that we're going to use then to create the watershed. So then we go to Watershed, input the flow direction raster, and that new snap pour point, and we're going to produce a raster watershed upstream from that. So, you know, the confusing thing is like you created this streamline, but that's an interpolation of the flow accumulation values, and really what we're defining in the in the raster model is that for the watershed parameters, and so we don't want to snap to that stream point because we might snap off of the flow accumulation, and then we would miss it and really wouldn't create a watershed. So this should work. Okay, it's running to 100%. So it displays here in 1 second. Now, boom. There it is. It's a pretty funky little watershed. If we turn off the stream itself, you can see that it actually doesn't have a lot of local contributing area through that Graben, and probably is an engineered channel through there. We can also see that there's other channels kind of distributing off of it in a few places nearby. So really weird watershed. So that's what that is, but it did work. The next thing you do is this. So we want to then go back, and basically this is a watershed raster, and the value is just 1. Watershed is there. So we want to take that and turn it into a polygon, and we can do that under this conversion tools box. So we just open that up and we say from raster to polygon. Input that watershed and pull out a new polygon. So there's the polygon. The cool thing about that is we can then use that as a clip if we want. So we could clip our DEM or this difference map, anything like that. So we got our cookie cutter. Of course, my watershed is not complete. I didn't get all of it because my data set ended, but hopefully that's okay. The other cool thing, right, we can make it just an outline, and then we can kind of see where the watershed is as well. Okay, so that's the watershed. How do we extract up that profile? Because we made this stream right here. I'm getting annoyed with how thick that is, so let's go back and let's just make it this water line. Yeah, how about something a little bit better? No, not a black line. Let's type river, see what comes up. That's water line. Okay, I can go with that, I guess. Just doesn't show up very well because of that color scheme. Guess I'll go with that. I'll go ahead, black line, and I'm going to go back to the raster. And I'm going to change this to dashed. Yeah. Okay, so it kind of shows me where my stream is. All right. So from here, you can follow the tutorial that they provide to turn this Enoch stream. If we open the attribute table, we'll see that it has a number of different segments. We can dissolve them together, and then we can extract that as a profile. So go dissolve. And I can input that Enoch stream and dissolve it based upon object ID is fine, and run. So we should get a new stream, and in that one, we open the attribute table, and it's just one polyline, shows us that it's 9,000 meters long, so 9 kilometers. Okay, let's see if I can remember my 3D analyst tools. So we want to basically go to interpolation and interpolate shape, I believe. Creates 3D features by interpolating Z values from a surface. So we're going to give elevation data to that line. So we can input our surface, which would be our DEM. Oh, wait. Probably, yeah, that's fine. And then our input feature is this Enoch dissolve. And then this is going to be, let's call this 3D Enoch stream. And we can go ahead and run that. And you could specify things like how often you sample, but I don't think that's necessary. Oh, so it doesn't like 3D at the front. Enoch stream, and then I'll put a big capital Z, or I'll put a capital Z at the front. Z Enoch stream. Okay, my Z Enoch stream is here. I'm going to open that attribute table, and what you're going to see is now where it says shape, it says polyline Z. Going back to the other one, it just says polyline. And so the cool thing about that is if we open up create chart, we can now create a profile graph off of that. That wouldn't have been possible before. Okay, so you can see the profile graph, it's kind of going in opposite order. So 0 was up at the on the right side here. And then we have a big nick zone here that's likely either right here or downstream, just a little bit into there. There's some other nick zones. I really would like to know if they're here and here as well, because we do see some things as we come across the landscape. So the interesting thing will be, how do you go ahead and kind of highlight points along this profile and plot them on here as well? Unfortunately, you can only export this Z profile as a graphic. It's kind of cumbersome in ArcGIS Pro. And so at this point, I would suggest that you probably want to open up this feature in ArcMap and use the 3D Analyst toolbox to extract a profile that'll look just like this. And then you can export that as a CSV or text file. And then you can also locate next to that values of kind of position along the stream for other features. Let me show you what I mean by that. So the way to do that is we could go back to our snap point, right? Because that's kind of a point along our stream. And we could put in a few other points to see if they fall where that we think they should here. So if I go back to snap point and I go edit, I'm going to create some more points where I suspect there could be some relationship. So I want to see, say, for instance, if at the edge of this Graben, there is something in the stream profile. And what about over on this other side of the Graben? It doesn't have to be perfect, just has to be kind of nearby. I think there might be something going on right here, or maybe it's right here where you see this drainage incision. So now I've got 1, 2, 3, 4, 5 points in snap point. So if I open us up and I go to the attribute table, you can see all those points there. And so I can go analysis and save those edits. I'm going to add a field, and we'll just call this field name and change it to text. Okay, and then save that. Then I can go back to snap point, and I can say point 1 was outflow, the watershed. Point 2 is lower Graben. Point 3 is upper Graben. I think I have got these in the right order. Then I kind of skipped, didn't I? So I better highlight them. So point 4 is kind of possible nick and channel incised. So in yours, you'll have like stream inflows and geologic features that you'll want to locate. But this is something for now. Okay, so for comparison now, we have that. We could go into symbology. We could plot them by unique values, by name. Could add all those values and then give them weird colors. Right, so we could identify them, could change their size, etc. But I'll just leave them with these colors for now. Okay, so let's minimize this a bit. Okay, so there those are. Now, how we can figure out where they lie on this profile. That's why I had that up. Profile. So where do they lie on the profile? We can see the distance along the profile here. So what we can do is we can go back to analysis and we go to tools and we go ahead and create route. So we're going to input the Enoch stream Z Enoch stream, and upper left corner is 0. Let's think about that. Let me get a help button here. Okay, coordinate measures will be accumulated from the point closest to the minimum bounding rectangle's upper left corner. This is the default. Position from which measures will be accumulated for each output route. Parameters ignored when the measure source is a value from 2 fields. Accumulated from the closest to the lower right seems more likely because we start high in the lower right down here. So this seems like we need to choose lower right corner and go run. Oh, route identifier feature. Not happy with that. The field containing values that uniquely identify each route. Oh. I'm going to go back to Enoch stream to do this. And that is interesting. So hopefully this will work. Okay, so it created a route. Z Enoch stream creates routes. There it is. Okay. Okay, so now we're going to locate features along routes. So input the features, which are the snap points, and the create routes. And we need that arc identifier. So I'm going to probably a search radius. So it's going to look for, I don't know, hopefully I've clicked within 10 meters. Maybe I should go more, 20 meters of the stream. And yeah, so we'll run that and it should give us a table of where these snap points lie along this profile. So if I scroll down, snap point locate features along, open that up. But only did the first one. Did I have it selected? Yeah, I had one selected. You see, it says possible nick. It measured it at 381 meters. So if we go back here, that's way up here. It's not the nick that I was looking for. So you see 381 would fall around here. So anyways, yeah, what we need to do is we go back up to snap point and go to selection, clear selection. And we go back. Let's rerun snap point. And we'll say, we'll call it locate features 2. And try again. Processes quickly. We open it up. We can see that here are locate features. So they are located at, the outflow is at 5,686, which is interesting, right? Because these are not the same distance as we move along here. It's too much. That doesn't make any sense. So channel in size is at 1,000 meters. Boom, that's there. There does seem to be some little nick zone in there. Lower Graben and upper Graben. So upper Graben is at 2,242. So 2,242 lies here. No, it's here. And so the real shift is, in terms of the nick zone, is not on that, interestingly. The other one is at 4,377. Again, it's slightly shifted. Which is not that surprising if there's an incision across the Graben, that it could have worked its way to one side or the other. But yeah, some things don't quite seem to be perfectly aligned here. So it's something for us to work on. But hopefully you see from this that we can, if we properly align the features, and the problem here might be that we've not quite picked the snap point features perfectly. So you kind of want to make sure you get them in the right place, for one. Two, I think the profile seems to be too long. I don't know how we get 9,000 meters. We can see we're across the Graben pretty much before that. So other issue could be that maybe the way we interpolated the stream, we had to create a route from an earlier edition, not from the polyline Z, and that could have created an issue. But overall, the things to take away from this video are, how do you snap a pour point and then snap a pixel to create a watershed along the flow accumulation raster, and then how do we take a line, create a Z profile, and then potentially use locate features along routes to then plot where they lie on that profile. Okay. I'm sure you'll still have questions, but that's what I can do for now. Hopefully this helps.